Welcome to Measurement Module 6, Lesson 8, solving up to 3-step word problems involving volume. Calculators are allowed for this class. Now, although volume is quite a simple topic, you may often find that word problems seem rather confusing and difficult. However, as long as you understand the basic principles behind it and work it out systematically, it is actually quite easy to score well in it. Alright students, this is the objective of this lesson. Solve 3-step word problems involving volume. Question 1. Find the maximum number of 9 cm Rubik's cubes that can fill a carton measuring 50 cm long, 45 cm wide, and 40 cm high. The dimensions of the Rubik's cubes are 9 cm by 9 cm. Okay, now unlike with liquids, a solid cannot completely fill a space. Therefore, we have to find out how many Rubik cubes can be lined up to fill the length. That means how many cubes can you put over here? Follow the red light again. How many cubes can you line up? So what we can do is we can take 50 and divide it by 9 and we will get the number of cubes that you can line up. So let's write that down. Okay, number of cubes. Let's calculate by number of cubes. And then we will do it individually for the length, breadth, and height. Okay, number of cubes. Now the number of cubes to fill the length. The length is 50 cm. The length of the cube is 9 cm. So you take 50 divided by 9 and you realize you get 5 with a remainder of 5. Are we interested in the remainder 5? Technically we are not, because we know there's going to be space over there. Okay, so we can put 5 on the length side of it. What about on the breadth side of it? So fill on the breadth side of it. Let's calculate breadth. 45 cm divided by 9 and you get what? 5. You get 5 with no remainder. That means 5 Rubik cubes can sit perfectly without any gap. What about the height? The height is this, 40. You realize that the height is 40, also divided by 9. And you get 4 remainder, 4. Once again, we are not really interested in the remainder here. We are only interested in how many Rubik cubes can we put inside. Okay, now let's kind of look at the diagram again. Okay, before we get to step 2. We'll realize that on the length side of it, we can put 5. On the length side of it here, we can put 5, right? On the breadth side of it, we can put 5. When we put 5 here on the length, there's going to be a small gap here, which is okay. On the height, we can put 4, and there's going to be a small gap on top. Okay, now to find the maximum number of Rubik's cubes that can fill the carton, just multiply all the figures up, which is 5 times 5 times 4. 5 on the length, 5 on the breadth, 4 on the height, and you get 100 in one carton, and that is your final answer. Remember, you can ignore the remainders. All right, we are done with question 1. Question 2. Tank X contains a metal cube of side 4 cm. Tank X was then filled with water up to a height of 15 cm as shown. The water in tank X was then transferred to tank Y. What is the height of the water level in tank Y? Look at both the diagrams, look at all the dimensions that are given. Now, first we find out the total volume of the water and the metal cube in tank X. So that is step 1. Look at the dimensions, it's 30 times 20 times 15. 15 is the height of the water level. When you do the multiplication, what do you get? You get 9,000 cm cube. Now let me reiterate, what does this represent? This is the volume of the water plus the metal cube. Now, if you want to find out the volume of the water alone, then you've got to subtract the volume of the metal cube. So let's find out the volume of the cube. Okay, you know the side is 4 cm, so it's going to be 4 times 4 times 4 equals to 64 cm cube. Now this is the volume of the metal cube. Now let's take the total volume, which is 9,000. And let's subtract 64 from there. 64 is the volume of the metal cube, and the answer you get is 8936 cm cube. What is this? This is the volume of water alone. Now let's pour this into tank Y. Using the reverse strategy, we can find the height of the water level in tank Y, which means you take 8936 and you divide it by the base area, which is 16 times 10. What do you get? You get your final answer, which is 55.85 cm. Well done. Moving to the next one. Question 3, Marat. I love the name, Marat. Marat bought a rectangular fish tank measuring 60 cm by 40 cm by 25 cm and began to fill it with water. Look at the diagram to your right. Water flowed from the tap into the tank at a rate of 12 liters per minute. As you can see, we are combining volume plus rate and speed. How long did it take Marat to fill the tank completely? Look at the diagram. First, we find out the capacity of Marat's fish tank in liters. So that is step 1. All the dimensions are given. 60 times 40 times 25, which is equals to 60,000 cm cube. But if you look at the question, right, it tells you that the rate of water flow is 12 liters per minute. So why don't we go ahead and convert the answer 60,000 cm cube into liters, divided by 1,000 and you get 60 liters. Now, let's see how long it took Marat to fill the tank. Step 2. Based on the information given, 12 liters equals to 1 minute. It took him 1 minute to fill 12 liters. If 12 liters is 1 minute, so 1 liter is going to be 1 over 12 minutes, right? If 12 liters equals to 1 minute, 1 liter is going to be 1 over 12 minutes. So what about 60 liters? 60 liters is going to be 1 over 12 multiplied by 60. Do the math. What do you get? 5 minutes becomes your answer. And that is your final answer. It took him 5 minutes to fill the fish tank. Well done. Well done, students. I'm really excited. We have completed lesson 8 and we have also completed everything in measurement. Now it's time for you to attempt the quiz, ace it, and go score.